Welcome students. In the engineering geology, we are seeing about the natural disaster and its causes. So last few classes we are seeing about the earthquake and also now we are seeing about the landslide. Okay, the landslide, already we saw what are the causes, what are the classification of landslides. Now we will be seeing about the measures to be taken to prevent their occurrence at landslides and some case studies we will see. Okay, so again and again I am giving you this one. This what is a landslide? Landslide is nothing but a downward or outward movement of the rock or a land mass, right? It may be a soil, rock or vegetation under the influence of gravity. This is the general definition. But as a geologist we will be saying it is also known as the landslip. That is a geological phenomenon that includes a wide range of ground movements such as rock falls, deep failure of slopes or shallow debris flow, everything that we call it as the landslide. Debris comes under the broken houses, that is from the houses or the lands, trees, everything, all that is unwanted materials, we call it as the debris. And as a geological person, that is if you are a foundation person, that is a geotechnical person, then you will be seeing that the movement of the mass of the rock, that is where shear stress exceeds the shear strength. You can see how the entire thing is going down, right? Okay, very pathetic, right? So this is one of the landslide. You can see what is the effect. Okay, so here you can see how much boulders of rock, the debris, everything is falling from the because of this steeper things that it is falling. You can see even there is a warning that there will be a falling. So here the rocks, debris, the coastal, everything is falling there. Okay, you can see here. So it is an avalanche increase on area due to the heavy rain. You can see the muddy water. I told you that clear water will be turned to muddy. Here they have witnessed 21.36 centimeter, 203.6 centimeter, and they are quitting the persons from one place to another place with the help of the boat and other things. So with several trees uprooted in several parts of the district, everything you can see in Tamil Nadu state that management authority has given a red alert area, and you can see the people are stagnated there and there, and the persons are coming to cutting the trees. Well, 25 persons Arakonam has come to Ooty in order to remove all these things to take care of the people. See here, they can't go outside, they have to go. This is a very situations in the case of the students. We will see some of the occurrence of the landslide. Already this map you have already seen the landslide affected states, that is along the Himalayas, right? So okay, along the Himalayas there is a place where the landslide is getting affected. Okay. So this Himalaya region, this is a West Bengal, Sikkim is there, Darjeeling is there, these are the places, Assam, Guwahati, Tripura, everywhere. And also this is the next affected places is that this Karnataka, Tamil Nadu, Kerala, Maharashtra, and least affected is Andhra Pradesh, Orissa, this region. Because of the rain, everything is affected, and these are the least affected place. Okay. So we will see the case studies. One is from the Western Ghats. The other is from the Northern Ghats, that is North India. So the Western Ghats we have seen about, we will see about the that is Kerala, and the Nilgiri transportation corridor we can see. We won't see, only two things I will show you. One is the Kerala, right, in the part of Kerala, and the next one I will show you the Darjeeling. Okay, so these two case studies I will say. When we are taking the case studies, we have to take all these factors. That is, what is the community base, what are how this area formed, what are the things, what is the historical record is there, what are the object oriented, any image or any satellite image we have to take, an image interpretation we have to do, whether what are the cut slopes are there, where there is a geological modification has happened, or whether already a landslide has been taken, what are the dynamic modeling, everything that we have to take, and we have to find out what is the risk that was there. So in Kerala we have taken an area called as Arvikal. Aravikal catchment is an area where it covers 9.5 kilometers square and it is in the subcatchment of Tikkovil river. Tikkovil river is a river that is falling from the hills, it is there, and Aravikal catchment is of 9.5 kilometers square. And here the history of debris falls during the monsoon was there. Already there is a monsoon, means there will be a landslide. That movement, flows of debris will be already there. And dominant work type, that is chalconites, and it will be there. Okay. So UNTTIC says debris flow will be there, and the research catchments will be there. Rubber plantation area will be there, and the clear relation land use, that is the landslides. Okay, already it is an area of landslide. So here there is the debris flow. All the types of debris will be flowing around there, and the main area there, it is the rubber plantation. Okay, so this is the main study area. It is this one. This is the Aravikal catchment. This is a full catchment area of 9.5 kilometers long. Here there is a Peringalam landslides. Already it is a landslide zone. So here in this area, that they have taken this area as the study, right? You can see this is the Kerala. In the Kerala, this area they have taken for the study. Okay, Kerala is a part near to the South India, near to our state, Andhra, right? So this is a study area. So what would have happened after a landslide? So what happened means, there is a 2005, there is a debris flow was there. Already there was a flow of debris was there, and due to landslide also there was a debris flow in 2005. They have actually this this landslide we are finding out in the year 2013 what is happened. Okay, so what happened in 2005 itself, there was a debris flow and runoff was there. In 2007 there was a soil slip. Movement of the soil was there. Here you can see this movement of the soil was there. And in 2007, 22nd, you can see that is because of the pore pressure, difference in the pore pressure, the entire area of the soil was moved down. And this area, that is, you can see here, there is another landslide was there. Small landslides were there. Okay. So because of all this landslide, what happened? In a very good monsoon areas, the entire area came down. So as a storm was, which killed around 2,350 members. Okay. So the next one, it is in the Darjeeling Himalayas. Darjeeling, all of you know where is Darjeeling, right? Everyone wishes to see this place. It is in the from the West Bengal area. It is the Darjeeling is there. This is a study area that was taken. Actually, I have taken it only from the net to the study area, and it varies from 236 to 2189 meters, and annual precipitation is 2000 to 5000 mm. It is always raining in that area, right? Because in the Himalayan ranges, Cherrapunji, everything is there, Assam is there, almost throughout the year there will be rain. And the metamorphic rocks of the Himalayan range was the fold thrust belt. And the foreland molasses basin is in the south, and main boundary fault is there, main central thrust is there. You can say this is the study area that is there. So here the Sikkim is there. Here you can see this is the main part of the landslide area. So most landslides are structurally controlled. Actually it is having a deep seated rock wedge. That is, wedge means it is a rock is like this. Okay. So whenever is there, the rock falls down, or there will be a landslide will be there. There will be always a deep seated ridges are there. So when the new layer of rocks are formed on the top of it, then it leads to the failure. Plain failure along foliation surface in shear phyllenitic rocks. Toppling caused by the steep dipping. So these are the three types of failure. So maybe it may be due to this steep edges that is there, and also this plain failure, almost a failure. We have talked about the fault. The fault zone is very high here in Himalayas. So along this fault zone there was a failure is there. And the next one, it is the toppling. Toppling is nothing but the newly formed rocks. Now it will topple down. Topple means it will. This is a rock layer, means this rock layers will topple, that is move like this, roll down. Okay, so this is the Himalaya you can see. So here this is a Darjeeling area where you can see the heavy landslide. Here you can see the next one. There are two landslides in that area in the same place. But landslide is not so common in the Darjeeling, and you can see how the landslide has taken place. The entire landmass have fallen and it has gone to the deeper area. This you can see. This is another view of this, and you can see that there was a fault plane. I told you now the fault plane along which there was a very bigger movement. Maybe they also, told that there is a small trigger also was there. So that also leads to this. And you can see the entire road is full of damage. The entire road is damaged. You can see in the road also a small part of roads has been washed away. So here you can see already the roads will be like that in the Darjeeling area. So there is a forming that road, this entire area was landslided. So you can see the road was washed away, everything is there. And also you can see the stagnated of the vehicles because of this rock falls were there. And you can see because of the rock fall the entire vehicle has been pieced to the piece. So another one earthquake in July 2004. This is caused is due to the debris, that is thick debris and steep gradients and building of water pressure areas. And it is a pressure, it is a technically highly disturbed rocks. It is a earthquake zone. Already it is an earthquake zone. So it is mainly formed of dolomites, phyllites and quartzites. So it is actually it is made up of a landslide zone. So every terror is there in the Nepal. I told you Nepal is nearer to the Himalayas, right? The Himalayas is in Nepal, right? It is in the hilly areas. Already it is a earthquake prone zone. So that it has sediment, sandstones, limestones which are easily triggered and easily it can be slided. So maximum it is also a layered rocks that are found mostly. And the water volume perforated, the pore pressure is very higher in the underground soil. These are the things that were there. And what are the effects means? Actually the river channels has expanded 2 to 4 times. This was noticed when this before this landslide was taking place in the Nepal. Okay, and 24 people killed, 2 seriously injured, 1,407 members were affected, 116 cattle, 1,446 houses, 15 schools were also destroyed, 7 bridges, 15 schools, 1 health post, thousands meters of drinking water pipes, highway feeder roads, trails were also swept away, hundreds of hectares of land with agriculture crops were injured. A loss equivalent to 540 millions, right, was estimated by that disaster. So what is the solution? How to get the mitigation effect, or what is the solution for it is that large trees should be grown in the unstable part, right? Large trees they should be grown in the unstable part, and networking of simple extensometer should be made. A study has to be made by which we have to be taken care that the vegetations are very good, the trees are planted properly, and this landslide mitigation sensors has to be given there. This is what the solutions they have made, and they have also given a peg lines should be establishment. Peg lines is nothing but a small indication that there is a like this they will be keeping, or they will have a pegs like this. Within a nailing they will be keeping into it, and they will have the indication of the peg lines. And alternately they will be finding out whether this peg line has any changes, any disturbances, any movement. Depending upon that, they will find out there may be another landslide. Cracks must be healed, and the soil stabilization method has been done. And the embankment of the rivers has been initiated, by which the rivers are already widened, and the retaining walls embankment has been given so that the rivers will not get overflowed. And extraction of sand and gravels from the river should be stopped. This is another thing where the rivers itself will be very damaged, erosions will be more, everything. So they have stopped all these things. Okay. And the selection of stable sites of settlements and other construction, and the land use guidelines and building codes are strictly formulated, and it was strictly that is followed in the Nepal. So here you can see. So here the landslide, it was like this. So from here it forms and it forms the debris on the bottom. Debris on the bottom we call it as the talus. So a convex slope, straight slope and concave slope. This is the weaker rock layer. Here you can see here. This is the main thing that you can see the hilly areas where the landslide mostly happens. So the next as a summary of this landslide, we know landslip is a geological phenomenon that includes a wide range of ground movements such as rock falls, deep layers of slow, shallow debris flow. And as a geotechnical person, we will tell the shear stress exist the shear strength. Then the landslides are defined as mass movement of rocks, debris or earth down in a slope and have come to include broad range of motions whereby falling or sliding or flowing under the influence of gravity. So the thing is with either with earthquake or flood or the volcanoes, this landslide may be occurring. And also the high hilly areas are very sensitive to landslide from only from a topper coast to the bottom things. And also landslide can do greater damage and also change the entire geological features of that area. And also it will be very quick. Before we imagine what is happening, it will be very quick. And if a slippery material is present before the soil, then soil become heavy with water and prone to slip away, which causes the landslide. So here you can already see there is a slide from the land will be there, and the landslide is caused by the poor road construction. So poor road construction, there may be a deep, that slope may be deep cut like this, right? So instead of this line, they have cut like that. And here you can see the river bank collapse. Due to that, the water has house has been slided, and here the debris flow due to the heavy rain, the mud flow is there. There is a landslide here. You can see there is a steep thing. The rock falls from here. This is an eroding cliff, and you can see, right? These are the different landslides. So here also you can see that it will be main scrap, and from there, slowly it will come. So it may be a heavy area, but we are above that there is a sedimental soils and gravels. That is due to the sediments. This will occur. Okay. So we have seen about this rotational slides. So rotation, it moves along the surface of the rupture and it is curved and concave. Then transitional spread, and also it is a translational landslide. Next one, it is a creep, topple and rock fall. Topple, I told you now, it will rotate and fall. That is, it is toppling of the effect. And the rock fall also will be there like this. The heavy rocks will fall from one place to another, right? So these are the different things. And creep is nothing but the slow movement of the things. You can see these trees are all curved now. Here the fences are curved. That's are mainly due to the creep. It is a slow movement of the soil layer or the rocky layer that happens for several years, right? It will slowly, because of these trees it will be minimized, but when you are going for a this is a removal of the trees, then this will occur. Vegetation is very important, and these are the landslides that affects the roads, rail lines, lines of communication, settlements, river flows, agriculture protection, land area, flooding, water availability, flora and fauna. And fatalities depends upon the place and time of occurrence. Estimated casualties per year worldwide, it is 600 to 1,000 persons that they die in the landslide every year throughout the world. And what are the hotspot is that steep slopes and weathering, high mountain ranges, sheer cliffs and steep and sided river valleys, where volcanoes erupt, and also coastal areas, and also where earthquake is there. So here you will see some of the effect of the landslide. So here you can see. So how much of land has been demolished. Here the full area of persons who are residing, the fully, not only here, you can see here, the mud flow, the color changes here. So this much part has been affected. Here you can see, due to this rock soil and flow is there, one vehicle has been damaged. We don't know what are the things that is there underground. Here you can see the entire geographical features has been affected. Due to this flow of this rock, this landslide, the entire place has been affected. The geological conditions has also been changed. So you can see here This is a very primal area where the roads are affected because the roads were for construction of the roads in the this hilly areas. If the hilly slope is there, if I have to construct a road here, I will go for a cutting of this part. So make this part an unstable area. So the land here it will slide means it will affect the road. You can see here, from here it has slided here. So this has become a landslide. Here you can see the landslide because of its slided part. Okay, so because of the cutting or laying the roads, that layer becomes a weak layer. Okay, here you can see the rolling of the rocks here, and it has completely blocked the roads. Here you can see this. There is another thing because this is near the river. Also, the water always it is percolated here. So underwater pressure, pore pressures are much higher. So due to this pore pressures, what happens? The shear strength is weaker in the bottom layer. This is the soil layer which has made this place to landslide. So here you can see that the bigger mass of the land has been slided, blocking the entire busiest highways. Here the entire that is the whole area has been damaged. So much of houses, everything has been damaged. You can see the debris that is falling on the road everywhere. This is also you can see, this is mainly because of the subsidence effect. Subsidence effect is the underground effect where the soil becomes very loose. This is mainly due when there is a rain, heavy rain, this happens. And you can see that washing of the entire area here. And this is another thing where liquefaction effect happens. Liquefaction effect is nothing but due to this shear stress high and shear strength low, the water that is underground, that is bottom subsurface level emerges to the surface, which will create this. This is a very phenomenon which occurs often due to landslides, or it may be due to this liquefaction. That is due to landslides or due to earthquake it happens. And I will say this is the next one. This is you can see some of the pictures related to the landslides. You can see here the damages that are caused due to the landslides. So as a summary, what I can tell you is that the landslide preparedness and that is not removal of trees, proper runoff, proper giving space for the water to flow, and also to monitor the landslide area, not constructing the houses in the area, following the IS code, everything can prevent the landslide. So landslide is a natural and also man-made disaster. It is also not a natural, that is a combination of natural and man-made. So it can be prevented by several measures like plantation, monitoring groundwater, and also engineering, construction, etc. Okay. So as with this I complete this landslide. We have seen earthquake and we have seen landslide. So a kind gesture can reach a wound only by the compassion and can heal. In the case of a natural disasters, we have to give a helping hand to the persons. We have to avoid the things as far as possible. From my side, we have to avoid the reasons that is causing this natural disasters. Thank you.